Welcome back to All This Math. I am Assata, your co-star, and then I have here with me the amazing Professor
Parker.
There you have it. It's right there.
Glad to see you. Glad to see you back in one of these videos. It's been a while since you recorded a video with me. All right, so yeah, I got Assata here with me. We're gonna do a little lesson on finding factors of numbers, right? We're gonna talk about what factors are. We're also gonna talk about what multiples are. All right, try not to get too distracted by Assata dancing around. She's got a lot of energy, you know what I'm saying? Before we get started though, notice I have my Texas Southern University sweatshirt on, all right? This is one of my favorite HBCU pieces, one of my favorite pieces of HBCU paraphernalia, right? Texas Southern University, established in 1927, right? So one of the HBCUs established much later than a lot of the other ones, like my alma mater, established in Morgan State, established in 1867. So this came in the 20th century. And in case you're wondering why I got all these books in my hand, is because there's a brother, an ancestor, who actually earned his master's degree from Texas Southern University, who goes by the name of the late Dr. Jacob Carruthers. Dr. Jacob Carruthers. Assata, do you know who Dr. Jacob Carruthers is?
No.
Okay, so that's fine. Assata doesn't already know who Carruthers is. She's heard me say his name before, but she doesn't know a whole lot about him because I haven't taught her a lot about him. So now I begin the process of teaching her about who Jacob Carruthers was. So Carruthers was a brother who was one of the co-founders of, or founding members of ASCAC. ASCAC, you've been to ASCAC conferences before, so you know about ASCAC. You used to come to the ASCAC study group we used to be in when you was a youngin'. You was like 2 or 3 years old. You used to be in there with me and Naseem and the elders and everything, right? Remember down the UNA building, down on Cecil B. Moore, 16th and Cecil, North Philly? All right. She acting like she'll remember. She was there though. I got pictures, I can prove it. But anyway, ASCAC is the Association for the Study of Classical African Civilizations. We actually just had our Mid-Atlantic Regional Conference yesterday, virtually, February 26th, 2023. That's when I'm recording this. And Carruthers was one of the founders. Then you had Asa Hilliard was one of the founders. Dr. John Henrik Clark was one of the founders. Dr. Yosef Beyakinen was one of the founders. Also, I believe Maulana Karenga was one of the founders. And I believe Dr. Leonard Jeffries was also one of the founders. If I'm leaving somebody out, please forgive me. I think Radhabisha Haru was a founding member as well, the elder Queen Mother. So, but anyway, I got these books in my hand. This book right here, The Preliminary Challenge, all right, is a collection of essays, all right, written by different ASCAC members about how we're gonna get out of the mess that we're in, all right, edited by Jacob Carruthers. Here's another one of his essays, Science and Oppression, kind of short, but real to the point and very serious, all right? Also, we got something that he authored, Essays in Ancient Egyptian Studies, all right? And this text he co-authored with, well, this is co-edited by him and Karenga. We have Kemet and the African Worldview, all right? So check that out. And also, one of his more popular texts, Medu Neter, all right, by Carruthers. And this book right here really changed my life. And I don't say that about a whole lot of books, but The Irritated Genie. The Irritated Genie is a book about the Haitian Revolution, right? We should all know about the Haitian Revolution because the Haitian Revolution is a great example of when African people, black people, when we won, right? They always try to tell us stories about how, you know, white people beat us up and beat us down and did this and did that, all right? But we often don't hear the stories about when we actually won, all right? And this is a great story about that. And it's factual. All right, and then last but not least, we got Intellectual Warfare, which is a collection of essays about just that, intellectual warfare, the intellectual war and also the intellectual civil war within our community that has to be waged and has been being waged for a long time. So just some of the books by Carruthers. And, you know, I figured I'd talk about Carruthers because whenever I think of Texas Southern, I think of Carruthers. That's the connection. That's a mental connection that I make myself. You know what I'm saying? So, Yeah, so now you know a little bit about Carruthers. You don't know a whole lot, but what we actually need to start doing is reading some of this stuff. We should actually start reading some of this stuff. You thought your lips were ashy? You thought you needed some lip gloss? That's what you thought? Okay. All right. So anyway, yeah, so we're going to start studying some of Carruthers' work. All right, so let me put these to the side, and let's get into our lesson. So basically finding factors, and this is kind of like one of those like math cheat codes, right? This is one of those math cheat codes that I think you all should understand and we all should be aware of. So Assata, I'm gonna start out with 6 times 7. I'm gonna write it on the board. 6 times 7. Now tell me what the product of 6 times 7 is.
42.
Okay, good. Now Assata knows her multiplication facts from at least 1 times 1 up to 12 times 12, right? We're going to start doing from 12 times 12 up to 15 times 15 because you need to know off the top like what 14 times 13 is or what like 15 times 7 is and all that off the top of the head. All right. So that equals 42. Now, when we're going to find factors, that means we're going to find other pairs of numbers that can multiply together and equal 42. All right. Now, this says using reciprocals. Now, what that means is this. A while back, I noticed something when I was doing some math, right? I realized that, okay, if I took half of one of these numbers and then I doubled the other number, I would still get 42 in this particular case. Because if I take half of 6, right? Assata, what's half of 6?
3.
All right, so if I take half of 6, I get 3. And what's double of 7?
14.
All right, so if I take half of 6 and I double 7 and I get 14. Now, what's 3 times 14? It's still 42, right? 3 times 14 is the same thing as 14 is the same thing as 10 and 4. 3 times 10 is 30. 3 times 4 is 12. 30 plus 12 is still 42, right? But there's a mathematical explanation behind this, right? And this will work for any pair of reciprocals. So look, so check this out, right? Now let's say I did 6 times 7 equals 42. And let's say I wanted to do half of 6 times 2 times 7 times double of 7. So half of 6 times 2 times 7. Now we know that 1/2 and 2 are reciprocals because a reciprocal is just, reciprocals are numbers that are inverses of each other, right? So basically if you have 1/2 and then you flip the numerator and the denominator, right? You flip them, now you got 2 over 1. Those are reciprocals. Are you okay?
Mm-hmm.
You sure? Mm-hmm. All right. So we got 1/2 and we got 2 over 1, right? These are reciprocals of each other. Because look where the numerator is here and look where it is over here. Look where the denominator is here and look where it is over here. The numbers switch places, right? And also 2 over 1 is the same thing as 2. So actually, no, I don't want to do an equal sign. So I could also say 1/2 and 2 are reciprocals of each other, right? So 1/2 and 2 are reciprocals of each other. All right, now this is why this works. This is why this will work. Because let's say I did 1/2 times 6 times 2 times 7, right? Now, if I did 1/2 times 6, I get 3. If I did 2 times 7, I get 14. We already said that 3 times 14 is 42 also. But with multiplication, the order in which multiplication is commutative. So the order in which you do the multiplication don't matter. So I could rewrite this as 1/2 times 2 times 6 times 7. Right? Now, if I know that this is still going to be 42, what's 1/2 times 2, Assata? What's 1/2 times 2?
2.
1/2 times 2 is 2? Really?
I didn't say it all the way. 1/2 times 2 is 2 too.
How is 1/2 times 2 going to be 2? If you got 50 cents times 2, how that's going to be $2?
Oh, it's $1.
Exactly. Which is what I was just talking about. 1/2 times 2 is 1, right? So that's going to be 1. And what's 6 times 7? Redeem yourself. What's 6 times 7?
42.
Thank you. So 1 times 42 equals 42. Right? So look, and this will work with any pair of fractions. What if I did 1/4 and I did 4? 1/4 and 4 are reciprocals. right? So what if I did 1/4 of 6 times 4 times 7, right? What's that going to be? Well, we already know, according to this rule, if we believe in this rule, we should still get 42, right? We should still get that. Now, if we put this in a calculator, 1/4 of 6 is 1.5. So if you had $6 and you wanted to split it evenly between 4 people, each person, if they get an equal amount, should get $1.50. They should get $1.50. Each person should get $1.50. So that's 1.5, right? Assata, what's 4 times 7?
28.
You gotta be quicker than that, sis. So 1.5 times 28. Now, because even if you don't know what 1.5 times 28 off the top of your head is, you know the relationship. Now you know the relationship at least. So you know that if all of these were 42, and all you did was multiply by reciprocals, you should still end up with the same amount or the same product, which is 42. All right. So just a little trick you can use, like if you want to define, like if you know you have a multiple of 42. Now, a multiple is the result you get after you multiply numbers together, right? Right? That's what a multiple is. The factors are the numbers that get multiplied together so that you can arrive at the multiple. So in this case, 6 and 7 are the factors, and 42 is the multiple. You paying attention? You know you better pay attention. So 6 and 7 are the factors, and 42 is the multiple, right? And then in this case, 3 and 14 are the factors, and 42 is the multiple. So if I want to find other factors, all I got to do is multiply each of the numbers by reciprocals of each other. So even if I did like, I don't know, 1/3 and 3, are 1/3 and 3 reciprocals of each other? Are 1/3 and 3 reciprocals of each other? Are 1/2 and 2 reciprocals of each other?
Yeah.
Yes, they are. So are 1/3 and 3 reciprocals of each other?
Yes.
All right. So if you know that 1/3 and 3 are reciprocals of each other, because 1/3 is just 3 over 1 upside down, and that's how you know that numbers are reciprocals. Also, the product of reciprocals is always going to be positive 1. That's always going to be the product of reciprocals. That's another part of the rule, right? Right? So 1/3 and 3 are reciprocals of each other. So if I do 6 times 7, but if I do 1/3 of 6 times 3 times 7, I know that's going to be 42. But look, 1/3 of 6 is 2. Let me get out the way. 1/3 of 6 is 2. 3 times 7 is 21. So that's how you know to find 2 more factors of 42. 2 and 21. 2 times 21 is 42. So this is just a little like what we call a cheat code, or like a math trick that you can use to find more factors. If you're looking for more factors of numbers, use reciprocals. Use reciprocals. So you gotta do. You can use 2 and 1/2. You can use 3 and 1/3. You can use 4 and 1/4. You can use 5 and 1/5. You can use 6 and 1/6. You can use 7 and 1/7. You know, 8 and 1/8. You know, you can do whatever you got to do. Now, all of those fractions that are reciprocals might not yield you actual factors, because remember, in order for a number to be considered a factor, it must be a whole number. All right, and in some cases you're gonna get decimals, like we had right here. So 1.5. So Assata, 1.5 is not a factor of 42. Right? 1.5 is not a factor of 42. And 28 is not a factor of 42. Because 1.5 is, even though 28 is a whole number, you have to multiply 28 by 1.5 to get 42. 1.5 is a decimal. Decimals are not factors. Factors are whole numbers. All right? So 1.5, even though you can divide by 1.5 and you can multiply by 1.5 to get the multiple of 42 or the product of 42, it's still not considered a factor because it's not a whole number. All right, so keep that in mind. But anyway, I just wanted to run through this real quick. Wanted to talk about Jacob Carruthers because I had the Texas Southern University sweatshirt on, and Assata was here. And this is something that I wanted to reinforce with her, something I introduced to her like last week sometime, and she didn't really get it. So I wanted to reintroduce it, sort of. or maybe reinforce it is what I'd rather say. So now hopefully she understands and she was paying attention and she's not, you know, overly concerned about her edges. You know what I'm saying? You know. All right. So did you learn something new?
Mm-hmm.
All right. So any closing remarks before we shut down? All right. Let me end this video because this little girl,
Peace.
she's so worried about her ashy lips.
My lips are not ashy.